And next up, we have Laurance Ashe, who's the Chief Executive at City Science.
Good afternoon. I'm Laurance Ashe. I'm Chief Executive of City Science. If you hadn't heard of us, we do transport analytics, modelling, software and data management for the transport and energy sectors. It's great to be here to talk to you today. Obviously, we've made our report openly available on our website. You can access everything that we've done in this project at www.cityscience.com. And as joint winners, we're also touring the UK, really trying to talk to transport authorities and spread the messages, the key messages in our report. So if you're interested in finding out more about that, please email me at this address or just come and talk to me after this session. So the heart of our project was all around a concept called dedicated driverless spaces. So a dedicated driverless space is essentially a certified section of road upon which a CAV can operate. That seems quite simple. So why would you want to do that? Well, first of all, it's a simplified operating environment. One of the key challenges of CAVs is ensuring safety in mixed traffic, in all types of conditions. What you can do with a dedicated driverless space is radically simplify the operating environment, making deployments more likely. The second thing that you can do is you can license the road space. So we can create a framework by which you license an operator to use that road space. We think that's particularly useful if you are operating public transport, last or first mile CAVs, or automated BRT. So just to give some context around that, maintenance could be a huge cost to the public sector. And that's something that I don't think the public sector should be embracing. We did some calculations. First of all, to get the UK's roads up to a standard where there are no potholes, the backlog's about £11 billion. We also looked at what you would need to do in terms of infrastructure, so ITS infrastructure, to get ubiquitous CAV infrastructure would cost the UK about £700 billion. And we think that's implausible and probably not a good use of money. What you can do with a dedicated driverless space, you've got an isolated scheme, and you can make a scheme-by-scheme assessment where the money and the benefits stack up. And the third thing that you can do with a dedicated driverless space is we can start today. The governance structures are all in place. The mechanism of local authorities planning a scheme, funding a scheme, that governance infrastructure is in place, and we can get these things moving. We can start designing a network of dedicated driverless spaces which will ensure that the UK is CAV ready, and we can lock in the benefits that we want, and we can lock out the disbenefits. And I'm going to talk a little bit about some of the disbenefits of CAVs because there are disbenefits as well. So in our report, we looked at 9 different typologies, implementations of dedicated driverless spaces. Essentially 9 different ways you could look at these things in different contexts. So we looked at last mile solutions, first mile solutions, business parks, CAV-only zones, autonomous BRT. We looked at freight. Freight's really interesting because in an autonomous world, all freight deliveries could be conducted overnight. That could save a lot of congestion. Managed cruise lanes and new developments. Sitting behind all of this, we reviewed about 100 academic and industry papers. So if you just want to find out what the current state of the art is on CAVs, I recommend going to read the report because there's a lot of information in there. Now, obviously, because of time constraints, I can't talk about all of these 9 typologies today. So what I'm going to do is I'm going to focus on the things which I think are going to be most relevant to the strategic road network because we're at Highways UK. So I'm going to talk about modelling for highways. I'm going to talk about business parks, where we think there's actually a huge incentive to think much more strongly about car-free developments. And then I'm going to talk about managed cruise lanes, which is specifically a managed lane specifically for the motorway. So I think it's really important to start from the perspective of congestion modelling, because one of the things I think we've got to do with CAVs is get a reduction in congestion. If all we do is implement CAVs and traffic goes up and congestion goes up, then I think we will have failed collectively. And it's very easy to be blasé about this point because we're continuously told that CAVs are going to be shared and CAVs are going to be optimised. Well, actually, the academic literature does not support that. It does not support that conclusion. So it's more nuanced than CAVs are going to reduce congestion. Actually, the effects of CAVs could be widespread. So we've simplified the literature into these 7 key drivers of congestion. I'm not going to go through all of the details of these today, but if you want to understand whether something's going to have a beneficial effect on congestion or not, you've got to make sure that in your strategic modelling, you're considering all of the different effects as an aggregate package. I think one thing that's really important to talk about that is in the academic literature is that taxi-based models do not score well on congestion benefits. And every academic paper that has looked at this has found, yes, the number of vehicles required goes down, but the vehicle miles travelled goes up. And you can understand why that might be the case, because like with Uber, the on-demandness of the system is requiring all of those vehicles to travel around with no people inside them. So actually, I think this is a really important point for cities and for anyone thinking about CAV deployments, because actually, and quite worryingly, this is currently the preferred mode of deployment or pathway for CAVs. So whether it's Waymo or Cruise or 5AI, they all want to operate a taxi-based system. What we find in our report and through our modelling is that public transport is absolutely essential. Public transport in cities can serve huge amounts of existing trip demand. But I also think this is really important from the perspective of the strategic road network. One of the real risks of CAVs is that they're so good, so cheap, that people start using them for long distance trips, business trips, and stop using the railway and stop using buses. And actually you can understand why CAVs may very well be able to outcompete those modes. But if you think about what that might mean from the strategic road network perspective, the outcomes, the impacts could be severe. So we think public transport's essential, but public transport itself needs to improve and CAV systems need to integrate with existing systems. One area where I think you can understand how this looks is around business parks. So this is an example business park. It's a business park in Coventry. We've just visualised it here in the City Science Cadence software. There's lots of examples of business parks like this. It makes sense for companies to locate their businesses close to the strategic road network because they get access to those longer distance trips. But the presence of those businesses also creates demand itself, and that demand then interacts with those longer distance flows. We think that huge amounts of business park commuter demand could be served by last and first mile shuttles. But I think what's most interesting and more compelling about this is that there's a huge incentive to minimise cars on these types of developments. So we analysed the land use in the Cadence software and around Exeter, and we found that for every 100-acre site, land value uplift of up to or more than £16.5 million would be available through the removal of cars. So I think that's a really good story. There's an incentive there for the developer. There's money there for the infrastructure. We can do that and reduce congestion, and we can improve the performance and resilience of the strategic road network by doing that. We also find that there are similar incentives for the removal of cars in new developments. So this is a hypothetical implementation of a range of infrastructure and design changes conceived here for the Taunton New Garden Town. In this particular case, we find that gross development values would increase by 65% through the removal of cars. So the final thing that I'm going to talk about is one of the typologies we looked at, which has specific relevance to the motorway network, and that's a managed cruise lane on the motorway. So essentially, what this does, it's an example of a dynamic, dedicated driverless space, and out of the 9 typologies, it's probably the one that's most challenging to implement. So to give a bit of context, a dedicated driverless space in a business park could be implemented today. Something like this, however, I think is probably 10 to 15 years away from even being at a trial stage, and the reason for that is that the safety risks go up immeasurably once you introduce that mixing of traffic. However, motorway driving is one of the preferred use cases when you talk to the public about CAVs, and we also think there are financial benefits from this sort of system. So how this would work, essentially the dynamic lane would work to maximise the throughput of the road network at any point in time. So the system needs two pieces of information. This is based on some maths in a paper from 2016. So the system essentially needs to know what the total volume of traffic is versus the capacity of the road. That's something that we do today, so we have that data today. The other thing that the system needs to know is what is the percentage, what's the proportion of CAVs within the fleet. Armed with those two pieces of information, the system can dynamically open or shut a dedicated CAV lane to continuously maximise the throughput of a motorway. What's interesting about this is when we look at the benefits and the benefit cost ratio, the delivery of a scheme like this could be orders of magnitude cheaper than a traditional lane expansion scheme, and given certain conditions, the amount of capacity unlocked could be 1.5 times more than one of those traditional schemes. So we think that as the proportion of CAVs in the fleet increases, it makes a lot of sense to prioritise these sorts of schemes at positions in the highways network where we have consistent bottlenecks or where there's consistent kind of meeting of capacity. So obviously I've gone very quickly through that today within my 10-minute slot. As I said, there's a lot of information in the report, a lot of information about the other 8 typologies. You can download it. It's openly available on our website. You don't even need to put in an email address. We're not going to come and hunt you down. So I encourage you to have a look. And if you've got any questions about this or any of our work, come and talk to me here or email me. Thank you.